So the good news is, yes, I did screw up. It's always about look at your answer and see if it makes sense, and my answer didn't make sense. I screwed up right here. When you rearrange for DO, it is equal to negative DI divided by M, not multiplied by M. So this is going to be divided by, so it's going to be 24 centimeters divided by 3/4. So DO is actually going to be 32 centimeters, not 18. So this needs to be 32 centimeters. And so the common denominator is not 72, it's 96. And 32 goes into 96 3 times, and 24 goes into 96 4 times. And so you end up getting 1 over negative 96. And so the F ends up being negative 96 centimeters, negative because it's a convex mirror, and therefore virtual. Okay, there we go. Saved by the video running out so I could figure out what the heck I had done. All right, so that's number 12. Now we have ones on the other page to do. The other page was 388. So on 388, starting with number 4, it says a concave mirror has a focal length of 10 centimeters. What is its radius of curvature? Hopefully that one didn't cause you too much difficulties. Where is my screen? There we go. So its focal length is 10 centimeters. Sorry, the light is that any better? Focal length is 10 centimeters. And we know R is equal to 2F, so it's 20 centimeters. Number 5. Light from a distant star is collected by a concave mirror. How far from the mirror is the image of the object if the radius of curvature, so the radius of curvature is 150 centimeters. That means F is 75 centimeters. And if you remember from a video the other day, I said if the object is distant, then DO is going to be really, really, really big, and for a star, it's really, really, really big, which means 1 over DO is going to be really, really, really small, which means the image is going to form at F, because if 1 over DI is equal to 1 over F, DI is equal to F, is equal to 75 centimeters. Number 6. The sun falls in a concave mirror and forms an image of 3 centimeters. Really what it's trying to tell you then is the focal length is 3 centimeters. Because if the image of a distant object, like the sun, forms at 3 centimeters, that means the F is 3 centimeters. If the object is 24, so HO is 24 millimeters high, and is placed 12 centimeters from the mirror, so DO is 12 centimeters. Where will the image be formed? You're looking for DI. So 1 over F is equal to 1 over DO plus 1 over DI. So 1 over, let me do it up here, 1 over DI is equal to 1 over F minus 1 over DO. So 1 over DI is equal to 1 over 3 centimeters minus 1 over 12. Get this camera situated better. Common denominator is 12, so 4 over 12 minus 1 over 12, which is 3 over 12. So 1 over DI equals 1 over 4. So DI equals 4 centimeters. Number 6. Somewhere here I have number 7. Oh, there's a part A that said use ray diagrams. Always good for me to look at the rest of the page. So using ray diagrams, here's my mirror, it's a concave, here's my F, here's my C, my object is out here. A ray going in parallel to the principal axis is going to get reflected through F. A ray going in through F is going to get reflected through the principal axis, parallel to the principal axis. My object, I'm cheating and not doing the lower ones, but honest, it would be there. It would be tinier, it'd be inverted, it would be real, it would be between F and C. And the C part, how high is the image? So HI over HO will equal negative DI over DO. Hi-ho. So HI will equal negative DI HO over DO. So HI equals negative 4. HO, they told us, was something that I don't remember. 24 millimeters. And DO was 12. So HI ends up being negative 8 millimeters, where the negative means inverted. Okay? All right, number 7 says, an object that is 30 centimeters from a concave mirror, so DO is 30 centimeters. 30 centimeters, how far was I supposed to go? To 9. 30 centimeters from a concave mirror, focal length 15 centimeters. And it wants to know if the object is 1.8 meters high. It's probably centimeters, not meters. Find the image and how high is it. So 1 over F is equal to 1 over DO plus 1 over DI. So 1 over DI is equal to 1 over F minus 1 over DO. 1 over DI is equal to 1 over 15 centimeters minus 1 over 30. So 2 over 30 minus 1 over 30 should be about 1 over 30. DI is equal to 30 centimeters, which should make sense because look, the object is at 2F, at C, which is C, and if the object's at C, the image should be at C, and if the image is at C and the object is at C, you should get the height of 1.8 centimeters. Now, if you want, you could do HI over HO is equal to DI over DO. There'll be a negative here, which just means upside down or inverted. But I'm pretty sure you'll get 1.8 because it's 30 over 30. All right, so that's number 7. Number 8 says, can't see it because the photocopy is blurry. A jeweler, oh, I really can't see it. A jeweler inspects a watch with a diameter of 3 centimeters by placing it 8 centimeters in front of a concave mirror. So diameter is really the height. I'm having light issues here. So it's 3 centimeters is the height, and the DO is 8 centimeters, assuming I can make out this copy, and the F is 12 centimeters. And it wants to know where will the image of the watch appear. So what's the DEI? So 1 over F is equal to 1 over DO plus 1 over DI. So 1 over DI is equal to 1 over F minus 1 over DO. So 1 over DI is equal to 1 over 12 minus 1 over 8. Common denominator will be 24. So 2 over 24 minus 3 over 24. So 1 over DI is equal to negative 1 over 24. So DI is equal to negative 24. Negative means virtual, and virtual means erect. And that's a good thing if you're a jeweler trying to fix a watch. You would like the watch to be right side up, wouldn't you, if you were trying to fix it? And then it wants to know what would its height be. So HI over HO is equal to negative DI over DO. Hi-ho, di-do. So HI is going to equal negative DI HO over DO. So negative 24 becomes positive times 3 divided by 8. So HI is 9 centimeters. So it's 3 times bigger than the original, which is going to make it much easier to fix.